Before we integrate anything, let's set up the key trig identities we'll rely on. Sine squared theta plus cosine squared theta equals 1. Sine squared theta equals the quantity 1 minus cosine of 2 theta divided by 2. Cosine squared theta equals the quantity 1 plus cosine of 2 theta divided by 2. And 1 plus tangent squared theta equals secant squared theta. There's also a substitution table for matching square root patterns. For the square root of a squared minus x squared, substitute x equals a sine theta. For the square root of a squared plus x squared, substitute x equals a tangent theta. And for the square root of x squared minus a squared, substitute x equals a secant theta. In every case, once you've made the substitution, you draw a reference right triangle. This is what lets you convert your final answer, written in terms of theta, back into a function of x. Now let's work through an example. We want to evaluate the integral of the square root of 4 minus x squared dx. This matches the first pattern, square root of a squared minus x squared, with it equals 2. So we substitute x equals 2 sine theta, which means dx equals 2 cosine theta d theta. Right now, before we do any integrating, we draw the reference right triangle. Since sine theta equals x divided by 2, we label the side opposite theta as x, the hypotenuse as 2, and by Pythagoras, the adjacent side as the square root of 4 minus x squared. Every side is labelled in terms of x and theta immediately, so there's no scramble later. Using that triangle, the square root of 4 minus x squared simplifies to 2 cosine theta. Substituting everything in, the integral becomes 4 times the integral of cosine squared theta d theta. Now we apply the half angle identity. Cosine squared theta equals the quantity 1 plus cosine of 2 theta divided by 2. Integrating gives us 2 theta plus sine of 2 theta plus a constant. Here's the trip up almost everyone hits, forgetting to convert every single theta term back into x. It's not enough to convert the plane theta, you also have to convert sine of 2 theta. Leaving any theta term in your final answer means the expression doesn't actually mean anything as a function of x. So using theta equals arcsine of x divided by 2, and reading the other two sides straight off our reference triangle, we convert each piece. The 2 theta term becomes 2 times arcsine of x divided by 2, and sine of 2 theta, using the double angle identity, becomes 2 sine theta cosine theta, which from the triangle is 2 times x divided by 2 times the square root of 4 minus x squared divided by 2. Putting it all together, our final answer is 2 times arcsine of x divided by 2 plus x divided by 2 times the square root of 4 minus x squared plus a constant. The teaching tip here is to treat converting every theta back to x as its own separate checklist item. Never bundle it in with the integration step itself. A good habit is to only cross out a theta term once you've written its x equivalent down right next to it so nothing gets left behind in the final answer.